Okay, a skier of mass 50 kilograms is skiing down an icy slope that is inclined at 20 degrees to the horizontal. Assume that friction is negligible and that acceleration due to gravity is 9.8 meters per second squared. Determine the components of the weight of the skier perpendicular to the slope and parallel to the slope. Okay, so what that means, the weight, our weight force is that red arrow there. Now, our weight force is made up of the components that are perpendicular to the slope and parallel to the slope. So it is basically just saying, work out what those two components of the weight force are. Okay, so the force acting perpendicular to the slope, so we'll call it F perp. If we check our diagram, we can see that that is going to be Fg sine theta. Okay, Fg, we should know how to calculate this. We've got a 50 kilogram skier and an acceleration of 9.8 meters per second. So, 50 multiplied by 9.8, what's that, 490? Cool. Times sine 20, so 490 times sine 20 is equal to 167.59. Thank you. Okay, so our force perpendicular to the slope, okay, is 167.59 newtons. Okay. That's parallel to the slope, isn't it?
Yeah.
Ah, that was a teaching moment. I'd see if anyone was going to pick up on that. So, sorry, that is parallel. I thought it looked a little small. So, sorry, that is F parallel. My bad. Yep. Lucky I had that diagram, or I'd never have realised my mistake. Okay. Sorry, that is, yeah, parallel is that one from our diagram. So perpendicular then, it's going to be, from our diagram, Fg cos theta. So 490 times cos 20, which is
460.45.
Thank you. Okay. So now, so while I'm going to joke and say that was a teaching moment, there actually is something valuable in me stopping up. Right? This is how I'm planning on spinning this. So, the reason that I could figure out my mistake was the common sense rule. Okay? I got a very small number for this. And looking over at my diagram, I realized it should have been much larger than that. Okay, so again, check your answers. Do they make logical sense? If not, double check what you've done. Okay? So, yes, I messed up, but hey, learn from my mistake. Don't do the same thing. All right. Part B. Part B. Determine the normal force that acts on the skier. Well, our normal force is the same. If you have a look at our diagram, it is the same as the gravitational force perpendicular to the slope. Okay? Exactly the same thing. So our normal, we've already worked this out, but our normal is going to be equal to Fg, what was it? Let's make sure I get this right, cos theta. Which was, what was it, 460? Thank you. Okay, so if we look at our slope diagram, our normal force is like that, and the gravitational force perpendicular is like that. So those two must be equal. Okay, because otherwise our skier would accelerate in one of those two directions, which we know they're not doing. All right, and again, that's from that diagram on the previous slide. It gives you the normal force. Then calculate the acceleration of the skier down the slope. Again, from that diagram, our acceleration is equal to g sine theta. This is easy, 9.8 sine 20. And that is 3.35 meters per second squared. Okay? That is a very, very useful diagram. When you get a problem like this, it makes it much more straightforward. All right, any questions? Okay, try the next one yourself.